You want to get class started, or because we're like 2 minutes late right now?
Oh yeah, my bad. Alright. Passing by. Passing touch. Sorry, that's of course you're doing.
Alright, take your seats, class. Alright, so today we're going to be going over the disk method and finding the volume. So please open up your book to page 432 and example problem number 2. You want to take your seat too so you can look at the board? Alright class, we're gonna go over how to do the disk method, and this is what the formula for the disk method looks like. So volume equals integral from A to B pi f of x squared dx. Do not forget the dx. A lot of you guys forget that. It goes from A plus work to C work if you forget that on your test, alright? So if we have an example problem, example number 2 is the volume 0 to 1. So this is our formula pi, plug in the function, which is root x squared dx. So we can always pull out the pi because it's a constant. So now we have the integral from 0 to 1 of root x squared dx. Like I said, do not forget the dx. You got it, Eric?
Yeah.
Alright, good.
Yeah.
Just making sure you're awake, alright?
Yeah.
So, root x squared is what?
X?
Good job! Alright, so now we have pi integral 0 to 1 of just x dx. So now we integrate it. So what's the integral of x, Eric?
All these questions, why not always me? I'm gonna go with x squared over 2.
Correct, good job. X squared over 2 evaluated from 0 to 1. Don't forget the pi. So now we get to do top minus bottom. So we have, plug in the 1s for x, so we have 1 over 2 minus 0 over 2. We get the pi out in front. So that's pi times 1 over 2, because this just ends up being 0. Multiply that out, it's pi over 2. And that's how you do it. Would you like to do an example problem, Eric? Want me to give you a problem?
Not really, but sure.
Alright, sounds good. Any questions, class? Eric?
Yeah, can we put that in decimal form?
You want to put this in decimal form?
Yeah, why not?
You want to be here all the way to freaking 2019, just writing this out. Do you want to do that? That's just a little bit. That took me like 10 seconds. You really want to do that? This is infinite. You can't do that. So keep it in this form, all right?
Oh, okay.
All right, thank you.
Yeah, no problem.
All right, Eric. Do you want to do example problem number 3 for me, please?
Yeah, let's see.
All right, thank you.
Okay,
Because I really want to know how you can do
the
your
volume
work.
of the solid obtained by rotating the region bounded by y equals x cubed.
All right, can you, instead of saying it, can you just please just write on the board, please?
Okay, yeah.
All right, thanks.
Y equals x cubed, y equals 8, and x equals 0. Around the y-axis, I believe.
Yeah, that's about right. I mean, I'm sorry I couldn't really teach you how to do this problem because the example problems that I always give are so much easier than the problems I give you, so. Do you need help on this?
Yeah, I think I do.
Jamie, do you want to help him?
I'd love to.
All right, sounds good. You two make an excellent team.
Okay, so should we graph this?
Yeah.
Okay.
Yeah, go ahead and graph it.
So, we'll label, x, y.
Yeah, never forget labeling the graph.
This is y equals 8 right here. So, x cubed, okay. Okay. And that's filled in. Do we fill this in? Is that?
Yeah, but see, the y equals 8 goes all the way across.
Oh,
So
like
it's about,
up
yeah,
here?
there you go.
All
Yep,
right.
so just the area and there's the volume we're
Okay,
trying to find.
Under the curve, got it. Okay, so now we have to use the equation, right?
Yeah, the volume equation.
Do you remember what that is, Eric? I just taught you the
Yeah.
problem just how to do it like
I
30
think
seconds ago,
so
and
that's
you already
volume.
forgot. So
Yeah. integral from a to b pi f of x squared dx. But in this case,
Yeah, we use y, right? Is that correct? Y.
we use y.
Okay.
Yeah.
Okay. Just making sure, Doc.
So
I'm not a doc, I'm actually a teacher, so you can call me teacher.
So we would go v equals the integral from a to b pi. Oh, we have to integrate it in terms of y, don't we?
Right.
So scratch that.
Scratch it.
So x equals the cubed root of y.
That's what I'm talking about.
Okay, so now we would go v equals a to b,
What's A to B in this case?
0 to 8.
That's what I'm talking about. Plug it in. Boom.
Pi of y to the 1/3 squared dy.
Good job.
Okay.
All right, Eric, what do you do now?
Well, we could take out the pi.
Because it's a...
Constant.
That's what I'm talking about, Eric.
And
Nice.
then-
And remember, you don't write that in decimal form either. You just
Okay,
keep it as pi.
Okay. And then we can square this y.
Okay? So do that for me.
Okay. Alright. 0 y 2/3 dy.
Good job. JB, can you integrate that?
So that's the volume equals pi. Integral from 0 to 8. And that's, is that 3/5 y to the 5/3?
Somebody passed their FSC.
And then-
Yeah. That's what I'm talking about.
I'll be seeing you next year, sir.
Yeah. It's okay, I understand. You suck at those.
Yeah, I do.
Wait, since we're already in, just evaluate this.
Oh, good job. I wouldn't even noticed.
0
Yeah, because I'm a distractor.
times up.
You are a distractor.
That's fine.
We're not playing that game right now, though, so we're trying to,
Yeah, you're right.
yeah, trying to be the player right now.
So now we evaluate it.
Yep. So
Top minus bottom. What's the top number?
I believe that's it's the one on top, right? okay, I'm just
Are you-
I'm just kidding.
Okay,
Alright, so
alright, man.
wait. Can't forget the equals option.
Just do you.
Yeah, I got you. So pi 5 times 8 5/3 minus 3 0 5/3 over 5.
All right, Jamie, can you solve that or what?
Okay, so
What's that equal?
we still have the pi up front. And if I were the guessing person, I would say that's 96 over 5.
That is very well guessed. I don't know how you got that on your first try, but that is the answer.
Whoa.
Minus what? What? You can't. You could do the first one, but you can't do the easiest one, really?
And that's just 0.
Yeah, okay, yeah, that looks good.
So then we have 96 pi over 5. Or, you know, we could put it in the decimal form.
Did you not? Were you sleeping during my my example problem or what?
No, sir.
Good.
Hey,
'cause
teacher,
you
I have a
never.
question.
Yeah.
Can we put this in decimal form?
You need to see me for EI,
Okay.
and you need to see me for EI too because, like, you could do gymnastics, but you can't take the integral very well. So
Yes, sir.
gymnastics. Good job, class. You guys can take your seats. Cool. All right, you guys did a great job today. So now I want you to do. It doesn't work. I want to do example problem. Oh my gosh. Oh, it doesn't work either. Almost made it. All right, example problem. 3, 5, 9, 11, 15, 69, 71, 101. You have 5 minutes, and this is all worth all your IP points. Go.